Okay, so like I said yesterday, today we are doing math. It's going to be free. Tomorrow we are going to have chemistry, which is going to be free as well. But like I said yesterday, we do have some tutorial videos on Moodle, Transcended Institute Moodle. Now, on our Moodle, we have the videos, the past papers, solved past papers, the tutorial sheets, and the explanation on each topic. So if you register with us, you'll be able to access all those things. On top of that, you're going to be accessing the live classes, which are going to be happening on weekends, Saturday and Sunday, where we're going to be reviewing all the topics which we have covered during the week. So for those who are going to be interested, if you want to register with us, I believe you have my number. You can text me on app, or you can text me on app, and then you know how to go about it. So now for those who don't have my number, this is my number, 0767. Let me start from here in case. So it's +26 0767 729927. So you can get in touch with me using this number on app if you want to register. Okay, so without wasting our time, let's start. What I like is when I'm explaining, if you know that you are behind, better you ask. Okay, better you ask. So the first question here is saying, given that A and B are non-empty set. Now, it is very, very important for you to understand the question. The question is saying, given that set A and B are non-empty set. Have you understood the question? What does it mean when they say they are non-empty set? Simplify A intersection open brackets B minus A close the brackets. So when they say non-empty set, what do they mean? Can someone help us? Let's do first. Who can help us? Who can help us? Yes, please.
It means there's something inside. Those empty sets are not empty. We have population inside. There are things inside, numbers or whatever.
Exactly. So meaning that we have the intersection of these two guys. In short, the intersection of A and B is not zero. That's the meaning. So now let's start. Okay, let's start. So now they're saying that they want us to simplify. We simplify A intersection B. This is minus A. The principle of math here is very simple. If I tell to say what is 4 minus 2, you are going to tell me that is 2. Meaning where there is 4, we subtract what? 2. So if I tell you that B minus A, it's the same as just saying B intersection A complement. I'm excluding now A. Okay? So B minus A is B intersection A complement. As simple as that. So this is going to be A intersection B this. Now we have to simplify this. So we are going to use what we call distributive law. we have to distribute A. So to distribute A, what we're going to do, this is what we're going to do. We're going to say, when I'm using distribution law, this is the same as A intersection. I'm getting this intersection. B, I put them in the brackets. Then I'm getting what is inside here. I'll put it here. Okay? Then it's going to be A intersection A complement. If you have got questions there before we continue, please ask. It's very important for you to know this beautiful law. If you have got questions, please ask. It's very important for you to know distributive law. Very, very important. Very, very important. We are claiming to know distributive law. Okay, let's just do a recap. So distributive law, if I have A intersection B union C, I can use distributive law and say this is the same as A. It's the same as just saying this times this, then again this times the C there. So it's going to be A intersection B. Then this union now comes here. A intersection C. That is distributive law. I'm just trying to distribute. Perhaps you have not done, I think, I don't know if you have heard of absorb, absorption. In math there is also what we call absorption law, but they don't mention it anyway. But I'm going to show you. Now we want to simplify this. We want to make it simple. Okay? To make it simple, believe me, sometimes if you're having some challenges on how to work out this, I would advise you to use a Venn diagram. So for example, if I can come up with just a simple Venn diagram here, this Venn diagram is going to help me. So let's say we have A here, and this is our B. So let's put numbers 1, 2, 3, and then we have 4. Now we can start with this part here. Well, let's start with this. Okay? If I start with this A intersection A complement, what is A intersection A complement? Which numbers can be found both in A complement and in A? Can we have a number which can be in A complement and in A? Is it possible? It's not possible, right? Now, sometimes you can know that it's not possible, but sometimes it's going to be, we understand. Sometimes it's going to be difficult for you to know to say, no, I can't have any number in A and A complement. If you want to know, if you don't know that A intersection A complement is empty set, this is what you do. Come up with with just a simple Venn diagram, like the one we have just come up with here. Now we are going to say what is our A. What are the elements in A? In A we have 1, 2. What are the elements in A complement? A complement we have 3 and 4. So do we have any number which is found both in A and A complement? No, we don't have. So that's the reason why this is going to be empty set. Then here I have A intersection B, then I have got intersection. Do you think we can have a number which is found in A intersection B and in empty set? So what is A intersection B intersection empty set? It's not union. It's intersection. Okay, let's use a Venn diagram. Yes, yes, please. It's empty set. So you can never have, in empty set we don't have anything. But in A intersection B we have something, right? What is A intersection B? A intersection B is 2. Intersection, empty set, we don't have anything here. We don't have anything. So initially, when it comes for the subset, I think if you can remember very well in grade 12, grade 11, grade 12, we used to say, when we were talking about the subset, I don't know if it was the subset where we were talking about if the element here which we have, we're going to have the empty set itself, then we also have the 2. Then here we only have the empty set. So the intersection between, so this is now this, intersect this, it's going to be just the empty set. So that's the reason why the answer here is going to be just the empty set. Any question? Do you have question or is clear? Yes, please.
Yes, sir. So the question is saying A and B are non-empty sets. So how come? Maybe explain a bit on how.
Oh, A and B, they're non-empty set. They're just telling you to say A and B, they have got elements. They're not empty set. That's the meaning. You get my point, right?
Sure, sure, sure.
Yes, they are sets. They are not empty set. They are sets. Esther, your hand is up. I believe you have got a question.
I wanted to ask on that part where can we find the same answer if we don't distribute the what is the set? If we just leave it like that, A intersection B intersection A complement.
It's possible, but it's going to be difficult for you. It's possible you can find. You are saying, is it possible if we can just do direct from here? This, right?
Yes.
Yeah, it's possible. Very possible. So this one you can only know using a Venn diagram. You can only conclude here using a Venn diagram. For example, the Venn diagram which you have here, Esther, you can see that if we can list what are the let's first find B intersection A complement. So let's list A complement. What is A complement? A complement is going to be what? Is 3 and 4, right? What is B? 2, 3, 4. Now let's find what is B intersection A complement.
3, 4.
B intersection A complement is 3, 4. Have you seen this, right? Meaning this is what we have here. Now I want us to, what is A? A is 1, comma 2. So this is A intersection B intersection. This one we have found that is 3, 4. So we want to find the intersection between this and this. Have you seen now? What is the intersection there? What is the intersection there? We have A which is 1, 2, then B intersection A complement is 3, 4. So what numbers they are found both in A and in B intersection A complement?
None.
None. So this is empty.
Yeah.
It's not 0, it's empty. Have you seen, right? So you can find, from there you can find A intersection B, A intersection open brackets B intersection A complement. It's possible you can find. But that one is going to require you to come up with a Venn diagram. But if you want to use distributive law, it's possible you can find even without a Venn diagram. You get my point, right? Okay. We go to B. Esther, your hand is still up. I don't know if you are still having some questions. I'm not really sure about that. Okay, so we go to part B or part 2, which is saying we have the universal. But before we go there, let's first solve the same question, but this question was now in 1100 test 1, which is question A part 2. It was saying given that X is a universal and A and B are subset of X, simplify. So the question is this. I want us to simplify this. Let me just write the question. So this was the question. So we simplify this. So allow me to shift this. I put it on top there. Shit. Okay, so I want us to simplify this. We know that when the complement is outside, once it comes inside, it's going to change, right? But before we do that, I would recommend you to do this. You first deal with what is inside, then we are going to come to the what? The complement which is out. So we're going to say we have A intersection B complement union. A minus B is going to be A intersection B complement. I hope no one is behind there. Next, let's bring this complement inside. Once I bring this complement inside, I'm going to have A intersection B. So complement and complement union, we're going to have A intersection B complement, then we're going to have a complement. Anyone who is behind there? Are we together? Are we together? Anyone who is behind? No one? Yes, Edith. Edith, do you have a question?
Is the union not going to be affected by the shift? Yes.
Oh,
Is the
sorry.
union
Yes, yes.
not
The u
affected by the complement?
exactly. Thank you for that correction. The union has to change. So let me start from here. Once you bring the complement inside, the union has to change. Any symbol there has to change. The union, so we're going to change the union to intersection. I didn't notice that. So it's going to be A intersection B. Complement is same as the complement are going to be cancelled, right? Intersection A. Here there's complement, so we have got a complement here. So now we don't have this. Now everything is okay. This is the same as just saying A intersection B, meaning the complement has gone. Complement will cancel each other. So we're going to have, if I bring that complement inside, I'm going to have A complement union B complement will cancel. This is what we're going to have. Do you have questions there? Do you have questions? Do you know that this is the same as saying B intersection A intersection open brackets B union what? Union A complement. I've not changed anything, right? Hey, I'm asking. Have not changed anything. Have you noticed? Reaching at this point, guys, let me tell you. Do you know that B union A complement is the universal? Not really. Okay, anyway. Let's do this. Let's come up with a Venn diagram. We have how many sets? We have got two. So we're going to have A and B. Allow me to put numbers. You can just choose numbers. One, I'm going to put 1, 2, 3. The universal, I'm going to put 4. We start with the first one. Okay, or we can start with this one. What is our A? Our A is 1, comma 2. What is our B? Our B is 2, comma 3. What is our A complement? Our A complement is 3 and 4. So now, I want us to put what is B intersection A. The numbers which are found both in B and A. What are those numbers? Come on. B and A, we have 2, right? Intersection. What is B union A complement? It should be 2, 3, 4. Not so. Now, Which numbers are found both in this set and in this set? 2. But what is 2? Exactly, meaning that the final answer for this is A intersection B. This is the best part of you using the Venn diagram to come up with the answer. You don't have to struggle. You just choose, you just pick the numbers, and then you see yourself say, okay, this is what is giving me there. Have you seen? Do you have questions? Or we go to the next question?
No, we go to the next question.
Thank you. So that was 1100. Now the next question is saying let u be the universal. We have the universal there as u. Then we have u, which is 1 not included all the way to 8 included. B the universal, and let a is equal to 5 is included, 8 is not included. B is going to be 2 is included, 6 is included. C is going to be 4 is not included, 7 is not included. Find, we have they want us to find A complement intersection B, then you have union B intersection C. It's possible you can find even without the number line, but the best thing which you have to do is to use the number line. Once you use the number line, everything is going to come out as perfect. Let me show you. So here is going to be my number line. Okay, here's going to be my number line, but at the same time I want you to know this. Do you know that if I can condense this is going to be the same as B. It's going to be the same as B what? If you know distributive law, B is common in this case. We can factor out B. Come on. We said this one here, it was, in case you are confused, it was like this. Distributing this one meaning that A has to appear twice. So here we have B, which is appearing in both sides. B is appearing twice, so B has to be factored out. Then it's going to be intersection open brackets. We're going to have A complement union C. This is, I can condense this. This is the same as this. You agreeing, right? So this is the same as this. So if this is the same as that one, then I can get the same one. I can say, here is my number line. I have been given the universal. The universal is from -1. I'm going to put -1 here all the way to 8. So this is my universal. Okay, I can even put here my universal from here, not included, but this is included. This is my u. Then next I can go to A. What is A? First I can see that I have 2. The numbers I have got 2. What else? I don't have 3, but I have 4. I have 5. I have 6 and 7. Now from here now I can see that A is from 5 all the way to, let's first find A complement intersection union C. A complement, A is initially from 5 all the way to 8. Is 5 all the way to 8. But now the complement, since this is included 5, meaning the complement is not going to be included. Meaning the complement is going to be from here all the way to here. That is going to be my A complement. We don't have anything here. What is my C? My C is from 4 all the way to 7. Is 4 included? No. 4 all the way to 7, both not included. So this is going to be my. So in short, A complement union C is this part here. This part. Now we have to intersect this one with B. What is our B? Our B is from 2. Let me use different color. Our B is from 2 included. 2 is included. All the way to 6. 6 is also included. That is my B. Now we want the part where these guys are intersecting this with what? With B. Meaning that I can get from this point here. This is where they intersect. Meaning my answer now in that case is going to be the same one, B intersection A complement union C. This is going to be my part. So we are not finding this, remember, we have just condensed it to this, but we are finding, this is what we are finding. So we are finding A complement intersection B union B intersection C. So the answer is supposed to be 2 included. From this point we can even see all the way to 6. So it's 2 included, comma 6 included. That is going to be our answer. Now you have to show this. They are saying that display it on a number line, the way we have done it, but as you can see it's a bit dirty. So what you have to do is, the only part which you have to shade is this part here. You can leave this part, so you can just shade the one I'm shading in red. That is the only part you have to shade. That is the solution. So you can leave this other part, don't shade it, and just shade the red part which I've just shown there. Is that okay? Is that okay? Guys, I'm asking.
Yes, sir, it is okay.
Perfect. Now let's go to this interesting question. Another interesting question which we can see there. Express 0.75 minus this in form of A over B, where A and B is they are integers and B is not equal to 0. This is irrational or rational? A number which can be expressed in form of A over B and B is not equal to 0 is rational, right? It's a rational. Now
Yes.
the issue here, guys, is very simple. You cannot do it directly because these things are different. This we have the second part, which is 0.03 bar. This is 0.030303. You can start now putting this 0303 from a vet hostel all the way to East Park. Okay, now to make it short, that's why we say 0.03 bar, meaning that those guys are just repeating. They're just repeating. So we can't subtract dialect here. So what we have to do is, we have first to deal with this part only. After that, then we are going to come to this. You get my point, right? So what I'm going to do now here is, I'm going to start with this. I'm going to say 0.03 bar. And I know that for me to express this in form of A over B, what I have to do is, I'm going to say x has to be equal to that one. X is going to be equal to 0.03 bar. Now this has to come from here 1, 2, which is going to be how many? 100. So another one is going to be 100. X is going to be equal to 3.03. You can even put bar, it's okay. So we have to subtract this. What you're going to observe here is that here this is going to give you, if you want, you can put this part here on top. Okay, you can put this on top and this one down, but it's the same. Even if you just do it direct, this is going to give you negative 99. Then this is going to give you what? It's going to give you negative 3. Now from here I can divide both sides by negative 99, even here by negative 99. These two will cancel. My x is going to be equal to negative and negative will cancel. I can see that there's a number which can go into 3 and 99, which is 3. 3 into 3 is 1. 3 into 99 is 33. Meaning that I've now expressed this to what? To this. Now, meaning that what I have now is 0.75 minus 1 over 33. But I know that this is a decimal. We don't use calculators in math. What do I have? So I can change this into fraction. I can do times 100. I divide it with 100, which is going to be 75 divided by what? 100. 75 divided by 100, if I divide it, I'm going to go back to what? To this. So meaning I've got 75 over 100 minus 1 over 33. But again, there's a number. I can make this math to be simple. There's a number which goes into 75 and 100. What number is that? 25, right? So 25 goes into 75 three times. 25 goes into 100 four times, if not mistaken. Okay? Minus 1 over 33. Now from here now, I can see that I can find the common denominator, which is going to be 33. Ah, no, 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 not 33. 4 doesn't go into 33. I think if we can remember get 12 math, if you want to find the common denominator, it's the same just saying 4 times 33. What is 4 times 33? 4 times 3 is 12. I can say 2, carry 1. Then this is going to be 12 plus 1 is going to be 132. Meaning that this 4 goes into 132 33 times. 33 goes into 132 4 times. So we're going to start. 4 into 132 is 33. 33 times 9 times 3 is going to give us 99. Minus 3 into 3 into what? 33 into 132 is going to give me is 4 times. 4 times 1 is going to be 4. 99 minus 4 is going to be 95. Then divided by 132. There is no any number which can go into these two guys. You can just end there. So the answer for this question is this one. Unless you have questions. Do you have questions? Do you have questions?
Yeah, okay, sir.
So I have got also part B, which is saying rationalize the denominator. This question is interesting. So we have 1, the square root of 2, 1 minus this. There are two methods which you can use, but the simplest one is just getting it dialect the way it is. You can just say this times the square root of 2, then you just change here, put plus. Then we do this time, this one we're going to get the square root of 2, 1 plus the square root of 3. Then this time, this one we're going to get, so we do now this is this times this. Now when it comes for this part, you just square the one having negative. So like in this case, you just square this, the one having negative. So I can square this, I can square this, I can square this. The one having negative, square it, then you are done. You get my point, right? So for example here, if I square this one, is going to give me a 2. If I square 1, is going to be 1 minus. If I square this one, is going to give me what? It's going to give me 3. Then I can see that inside I'm going to have this, and this is going to be negative 2. Negative 2 times 2 is going to give me 4. Negative 4. This is the simplest method. But there's another method. If you're interested to know another method, I can show you. I can divide negative. My final answer is going to be negative the square root of 2, open brackets, 1 plus the square root of 3. I divide it with 4. So this is the final answer. Do you want me to show you another method?
Yes.
This method which I'm going to show you is going to help you to solve. There's a question which came last year in final exam, where you have to say what is inside here. This is the root of 3. Just say let y to be equal to the square root of 3. Then you start now bringing to say 1 divided by the root of 2, 1 minus, you put here, you're going to put y. You replace this with y to make it simple. You get my point, right? Now I can distribute what is inside here. I can say that this is going to be 1, then the square root of 2 times 1 is going to be the square root of 2 minus the square root of 2 times y is going to be the square root of 2y. Now from here I can do times, I can rationalize the square root of 2 plus the square root of 2y, even here the square root of 2 plus the square root of 2y. Now from there what I'm going to do now, I'll do times. So 1 times everything here, we are going to get what is there. So we're going to have the square root of 2 plus the square root of 2y, everything divided by, remember I said you square what is having what negative. So for example, which one is having negative in this case? This one is having negative, so I'm going just to square this. It's the same as just saying this time this, we are going to get the same answer. So I square this minus, even this one I square it, and I'll end up having this. So this, if I square it, 2 is going to give me just a 2 minus, that is going to be a 2y squared. Okay, remember to say y is equal to the square root of 3. Let's replace now y with 3. Let me get rid of this first. I'm going to say the square root of 2 plus the square root of 2 times y. I'll replace it with what? With 3. I'll divide it with what? 2 minus 2. Then this, the square root of 3, we have to square it. So we're going to have the square root of 2 plus the square root of 2 times the square root of 3. Everything divided by what? 2 minus 2. Then this, if I square it, is going to be 3. On top there, I can factor out the square root of 2. I can say the square root of 2 open brackets, I'm going to remain with 1 plus the square root of 3, so that when I do times here, I'll go back to this. Everything divided by is going to be 2 minus 6. I'll end up having this, which is the same answer. This is going to give me negative 4. I can divide it with negative 4. I'll have negative the square root of 2 open brackets 1 plus the square root of 3 divided by 4. As simple as that. Is that okay?
Yes.
Do we have questions? Okay. Since we don't have questions, let's go to the next question. Given that z, this is the question which was it was giving you problems actually. Given that x, or given that z is a complex number and mi is greater than 0, solve the equation. Mi, in fact, so they're saying that solve the equation z squared minus 2z bar is equal to 2. Very simple and straightforward. Note that im denote the imaginary part. So they are just telling you, these are just simple basic things. They are just telling you that any imaginary number which you are going to have is supposed to be greater than 0. So once you find that you are solving the equation and you find that the imaginary is less than or is equal to 0, then that is not the imaginary. They have given you the condition that the imaginary is supposed to be greater than 0. That condition is very, 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 very important. Okay? So they are saying that the imaginary has to be greater than 0. So now they are saying that solve this equation. Z bar is just basically the conjugate. Imaginary, if you want to say z, you can just say z is equal to x plus yi, or you can say z is equal to a plus bi. This is a form of what? The complex number. Any form of complex number you can just come up with. That is just okay. So which one should we go with? Should we go with x plus yi or a plus bi? You choose.
A plus bi.
A plus bi. Okay, let's go with a plus bi. So if we say our z is equal to a plus bi, meaning what is our z bar?
A minus B.
A minus bi. Simple as that. Now our equation is this. They're just telling us to say where there is z, let's put a plus bi. So I'm going to say where there is z, we are going to put what? We're going to put a plus bi. Now we square it. Minus 2. Where there is z bar, I'm going to put a minus bi is equal to 2. This is an equation, guys. Very simple. Now I'm going to distribute this. This is the same as a plus bi. Again a plus bi minus 2 open brackets a minus bi is equal to 2. From here, guys, what I can do now is remember this is the imaginary, this is the real part. Okay, so this is the real part, this is the imaginary part. Now they are telling you that, meaning that we have gotten b to be bi to be the imaginary part, meaning that when we are solving this, when we are trying to find the value of b should not be less than 0 or should not be equal to 0. It has to be greater than 0, because the question, the statement is saying that the imaginary number is greater than 0. Okay, let's continue. What is a times a? A times a is going to be a squared. A times b, that one we're going to get a bi. Bi times a, we're going to get a bi. Bi times bi is going to be bi I squared. We're done with that one. Minus, let's distribute this one, we're going to have 2a. Negative, and this is going to be plus 2bi is going to be equal to 2. Up to that point, I want you to ask. Do you have questions? Do you have questions, David? Agnes Pili, do you have questions? Agnes Pili, do you have questions? Okay, let's continue. You don't have questions. Now from here, what I want us to do is we get the real part alone and the imaginary part alone. Remember when you're solving uh, the the equations with the complex numbers, what we normally do is we're going to get the imaginary part alone. So we start with the real part. So a, it doesn't have I. I'm going to get it alone. Or before we do that, we have to simplify this. A squared. This and this is going to give us 2abi plus b squared. What is I squared? So I can put minus b squared here, minus 2a plus 2bi to be equal to 2. Now from here I want to put the real part alone and the imaginary part alone. So a squared is a real part. What else? Minus b squared is a real part. Minus 2a is a real part. I'm going to put these in the brackets. What else do we have? We have also different thing which we can say plus 2a is a imaginary, ab is an imaginary part, it has got an I. Again 2b is an imaginary part, I'm going to put I. If I distribute this I, then I'll have 2abi plus 2bi. This has to be equal to 2. When you have got this equation here, you say the real part is equal to real part, imaginary part is equal to imaginary part. So here you are going to do this. You are going to say, so now what is, we have got this, everything here is equal to 2. Meaning that what is our imaginary part? We only have 2 here. What is our imaginary part? 0. It's the same as we have got 2 plus 0i, which is just the same as 0. So we are going to say a squared minus b squared minus 2a has to be equal to, the real part is 2. Let's get the imaginary part. The imaginary part is 2ab plus 2b is equal to, the imaginary part here is 0. Now from here you just solve these equations. After solving, you have to find the value of a and b. Once you find the value of a and b from this equation, just plug in a and b. That is the answer. Okay, now we can start solving this. Let's start with this. So what I'm going to do is this. I'm going to say I have 2ab plus 2b is equal to 0. I can factor out 2b. So if I factor out 2b, I'm going to remain with a plus what? 1 is equal to 0. If you know math, this is the same as 2b is equal to 0, a plus 1 is equal to 0. We can find the value of b. I divide both sides by 2, I divide both sides by 2. b, 2 cancel, b will be equal to 0. Remember, the point b is an imaginary part, but the point is saying the imaginary is supposed to be greater than 2, or greater than 0. So this was saying that b is equal to 0, meaning this is not the solution for b. You leave it there. That is not the solution for b. Let's go to a. So a, I can shift 1 to go to the other side, is going to be 0 minus 1. A will be equal to negative 1. I'm done with a. They have not given us any condition for the real part, which is a. So a is 1. After finding a to be equal to 1, I have to plug in these values in the first equation to find the value of b. That b which I have to find is supposed to be greater than 0. As long as it's going to be less than 0, that is not the value of b. As long as it's going to be equal to 0, that is not the value of b. As simple as that. Let's go. So we're going to say we are now done with this. We'll go now a squared. We plug in the values. So let's plug in the values. A is negative 1. We square it minus b is the one we are trying to find. 2, a is negative 1, has to be equal to 2. Okay. 1 squared, negative 1 squared is going to give us 1 minus b squared minus this, and this is going to give us what? It's going to give us positive 2. Has to be equal to 2. I can see that I'm going to have negative b squared plus 3. 1 plus 2 is 3 is equal to 2. Negative b squared is going to be equal to 2 minus 3. Negative b squared is going to be equal to negative 1. Negative and negative can go, therefore b squared will be equal to 1. Now from here we have to find the value of b. To find the value of b, we have b squared is equal to 1. We get the square root. Once we get the square root, this is what is going to happen. Here we are going to have plus or minus, meaning that our b is equal to plus or minus 1. But we have two values of b now. We have b is equal to 1, positive 1, and b is equal to negative 1. But the condition is that b has to be greater than 0. So this is not the solution. So the solution is this one. So we have found a and b. Therefore, our final answer, the equation now is going to be z. Is going to be a is negative 1. Our b is 1. So that one we can just say is just I. It's one I, but it's just I. So this is the answer for this question. Unless you have got questions. Yes, please. Yes, please. Yes, you can ask.
On that part, can you please repeat the explanation starting from the b is equals to 1 there? I'm lost on that part up to the
This
final
part.
answer.
This part.
Yes, up to the final answer.
Thank you. Another one who is having questions?
We
Yes, please.
so does it mean if we were to put where there is z squared, we put the value of z, where there is
Yes. We are going to find, yes, we are going to find 2. The answer is going to be 2. We can even prove.
thank you.
Yes.
So can you also explain the point where you said b is equal to 0?
B is equal to 0. Okay, yeah, that's where Edith, she's from asking the same question, so I'll repeat from there. Okay, so that's I should start from this point, right?
Yes.
Okay, perfect. But are you guys okay with the equation which we just came up with, where we said we came up with the equation which was I've even forgotten. Do you have anyone who was writing? we came up with, what was the equation? We came up with two equations. We came up with, I think it was a squared, if not mistaken, minus 2a minus b squared. Another one was 2ab plus 2b. This was equal to 2. This was equal to 0. Are you guys okay on how to come up with these equations before I start finding the values of a and b?
The
Yes.
second equation. On the second equation, where has the I gone to? Like two.
Okay, okay.
Where has
The
the I gone?
okay we had the, so let's start from here. The overall equation was a squared minus 2a minus b. Anyway, here we had minus b squared minus 2a, then we had plus 2a b plus 2b I was equal to 2. Initially this is 2 plus 0I. We're okay there, right? The imaginary is 0. So what we normally do here is we get the real part, like this part here has to be equal to the real part. The imaginary part has to be equal to the imaginary part. Now, the I which is here is going to be cancelled with the I which is there. That's why we just ignore the I. Because the imaginary is going to have the I, the imaginary this part is going to have the I. So I and I will cancel. Is that okay? The one, yes. So now let's start from here. People are confused here. From here now we are trying to find the values of a and b. So from there we are going to start with the first equation. Okay, the first equation is 2ab plus 2b is equal to 0. I can see that 2b is found in both sides. I can factor out 2b, 2b, yes. So if I factor out 2b, I can see that this part here, I'm going to remain with what? With a alone. Here I'm going to remain with a 1. If I distribute this, I can go back to that. Is that okay? Is that okay?
Yes, it is.
Now math, when you come up with this one, what it means here is that this one is equal to this one, and this one is also equal to this one. It is the same as you have this x plus 2, x plus 3 is equal to 0. At this point you are going to say this is equal to this is equal to this, not so. We're not trying to find the values. Yes, so even here we can say that 2b is going to be equal to 0. Then again you get what is inside the brackets a plus 1 to be equal to 0. Then you solve the values. Now for me to find the b value, I'm going to divide. You can mute your mic, Natasha. I'm going to divide both sides by 2, even here by 2. I can see that these they will cancel. B will be equal to 0. But remember, the condition here is saying that the imaginary part, which is b, is supposed to be greater than 0. So this we are saying that b is equal to 0 is not true. Meaning that this is not the solution for b. So you say this is not the solution for b because b is greater than what? 0. Then you solve now for a. A is the real part. They have not given us any condition for a. So you have to say a is going to be 0 minus 1. A will be equal to negative 1. You are done with a. Since you have found the value of a, you have to plug in the first equation to find b. Now, the b value which you are going to find, you need to get the number which is going to be greater than 0. So we now plug in the values where we said is this one. So I'm going to plug in 1, negative 1 squared minus 2, which is going to be negative 1 here minus b squared is equal to 0 or is equal to 2. This is going to give me 1. This is going to give me plus 2 minus b squared is equal to 2. 1 plus 2 is 3 minus b squared is equal to 2. I'll shift 3 to the other side, or it's the same as just saying b anyway. So it's going to be negative b squared is equal to 2 minus 3. So I'm going to have b squared is equal to negative 1, which is negative negative. Negative and negative will cancel. If negative and negative will cancel, I'm going to remain with b squared is equal to 1. Now, after reaching at this point, I have to get the square root. Once I get the square root, this is going to be plus or minus the square root of 1. So my b will be equal to plus or minus 1. So if I say plus or minus, meaning that b is equal to negative 1 and b is equal to 1. So you are going to say that you have got b is equal to 1 and b is equal to negative 1. But this is not the answer, because b has to be greater than 1. Meaning that this b is equal to 1 is greater than 0, so this is the solution for b. Then you have a as negative 1, you have b. Plug in the values in this formula. So meaning that our z is going to be negative 1 plus I. That is going to be our z. Unless you have questions. Do you have questions? Have you gotten the concept? Okay. So we are supposed to go to the next question, but time is not with us because we started exactly at 16:35, and this is 16:34, which is 1 hour exactly. So for today, I suggest we end here, unless if I've got questions. Unless if you've got questions concerning transcended. If you don't have questions, then we end there. Okay. Bye for now.